Well, here we are in the goat shed today on this fine summer's morning, being Wednesday, December 9th, 2020. Today we want to talk about score motors. Now, these are the thing that probably look the most frightening in any electromechanical pinball machine. And if you don't understand the way they work, I guess they can be. But realistically, they are fairly simple to understand and work out. Once you get the hang of it, it will help you in repairing and troubleshooting your pinball machines. So we started off back in the early days with score motor being this type, the carousel, meaning that it spins away like so. That's a Gottlieb one, but in the early days both Williams and Bally also used those. As time progressed though, I think it was Bally who introduced the horizontal score rule, where a series of switches sit on top of these cams like that, and some say these are a little bit easier to work on, which I guess they are, because it's much easier to unscrew the screws from the stack there and take each switch off, or if you undo that screw there and the identical one on the other side, you can lift the whole stack off at once. Let's talk about the Gottlieb carousel score motor. Now, as I said, these essentially are analog computers and they are the brains of the whole pinball machine. Now, they are set out in such a way where the switches are screwed onto a frame. As you can see, there's parts of the frame there. There's no switches there. And that's the actual motor. The motor is bolted on underneath. There it is there. And those motors do come out quite easily. They are held in by screws which go in here. And you get at those screws through these holes here. So you've got to turn the score motor around to align it with a screw. Like that. Oh, I just went past that one. Don't know if we can see down there. No, we're not going to be able to get it. But there's a screw straight down under there. Okay, so there's lots of switches on there and they all do different things. They're all on the schematic, but it's helpful to understand what's what. So, on a Gottlieb, they use this cam arrangement. Now, it's upside down. We're going to put it the right way up. The bottom part of the cam has teeth on it. Now, being a Gottlieb score motor, it's 360 degree circumference. And we have these cutouts here, here and here, which are rest positions for the switches. So the way that it works is that the one with the teeth is cam A. There are studs. That's the top of the stud here, and that's the stud here. There's three of those. That's called level B. The top edge is called level C. And then we can have level D and very top E. So that's the cam arrangement. A, B, C, D and E. Then we have several switch stacks in order. Now, those switch stacks are numbered. Now, sometimes on the Gottlieb games there are numbers. Yes, there they are there. That's number 2 and that's number 3. But if the numbers aren't there, and as you can see, someone's gone to a bit of trouble here writing things on the top of the cam. Not necessary. This stack here with no solder tabs on it, that's the motor brake. That's called stack 3.5. So the switches go in a clockwise direction. So 3.5, the next stack would be 4, and there's only 4 stacks. So this stack here would be stack 1. The lot I'm pointing to here would be stack 1A, 1C. And the next stack here would be 1D. Then we move on to stack 2. So this is stack 2C. And there's another stack under it there, which would be stack 2B. And that's a very important stack we'll talk about later. Stack 3C, 3B, 3.5 motor brake, and stack 4. So this is stack 4C. Now, on the cams we have dogs and dog carriers. This is the dog here, this black thing there. That's the dog. And that dog pushes in and moves the switch stacks, as you can see. So as the cam moves around, that dog pushes in. And this bit here on top, this is the dog carrier, what the dog sits in. Now it's important to know there's 2 positions those dogs can go in. See that there? So that one here is in the short throw. If the dog was fitted in there, it'd be the long throw. Now the only switch stack on a Gottlieb that is in the long throw is here, is stack 2C. Now that's a rule of thumb. Now we recently had a machine, it was a Gottlieb spinner card, where it was subtracting 2 credits when you started a game. And after analysing the circuit, the only thing that came into play really, beside the replay unit, was switch stack 2C. And someone had put it back together wrong and put that in the short throw position. And that throws the timing out, because these score motors are all about timing. So everything is set so that a switch stack goes on, another one comes off. And that's how the cams control everything. Now, on a Gottlieb, these things only move in the anti-clockwise direction, but the switch stacks are numbered in the clockwise direction. So you need to get the hang of that. Motor spins in anti-clockwise, switch stacks are numbered clockwise. Now, another switch stack we have here is stack 1A. So looking at this, remember we had stack 1C, 1D, 1B, and 1A. Now stack 1A is the stack that are on the gear fingers. So that's the impulse stack. So 1A is used for, a switch is used for resetting the score reels, and another switch is used for controlling the amount of pulses. So on one of these, there is 15 teeth, spaced apart by 5, so there's a gap in between. That allows for the timing of other switches to come on and off. So in that instance, how that would work is that how a machine scores, say, 500 points, we have a target on the playfield that says when lit 500 points, you hit that switch. With the ball, that only hits it once, but yet it scores 500 points. How does it achieve this? Well, it's achieved by what we call a lock-in circuit. Now, a lock-in circuit, as we can see here, we have, it's used when a relay must remain engaged even though the switch that originally pulled in the relay reverts back to its normal position. So in this case, switch 1 would be the switch on the playfield So we hit that switch, it closes, turns on the relay, but then we have that other switch there which says relay switch. That's a hold-on switch. It's wired in series between the relay and another switch labelled switch 2, which is normally closed. Now, if you look at that circuit, once the relay switch is actually closed, it completes the path to the yellow wire here, and it will hold that switch on till that switch releases. So what that means is that we were talking about on the Gottlieb score motor, we have switch stack 2B, and I'm just going to put my pointer there on that stack. That's that stack 2B there, and that's the actuator. So that's a normally closed switch. So after 5 or a third revolution, I should say, or 5 notches of that cam, that switch is going to be broken. So this switch here will open, and that will cut off the power to that relay, and pulse 1 scored 100, 200, 300, 400, 500. Now, I hope that makes a little bit of sense the way I've described it. And that's how it works. That's called a lock-in circuit. Lock-in circuits are also used on bumpers. So there's an example there, the jet bumper, the bumper relay there, and the jet bumper end of stroke switch. Same thing, the bumper relay switch closes, holds on till the end of stroke switch is opened, and that ensures that it's done its job. It's like an assurance switch. I was recently reading an article put out by a well-known guy. His name was Russ Jensen, I believe. He's no longer with us, unfortunately, but he wrote a very good book on stuff like that. Now, if that makes sense to you, and I hope it does, that will give you a little bit of information on how these things actually work. This is the score motor itself. As you can see, this shaft here, that's what the cam attaches to from underneath. There are 2 size shafts. There's a thin one and a thick one. So you've got to change the cam. The cams are the same, but the shafts, they change them. In the 60s, they were a bit thinner. And the other thing is, when you've got your score motor out, you need to also lubricate it. And this is achieved by dropping oil into that pad there. There's one on the bottom, and in this case, another one on the top. I drop oil in them till it starts to come out. It won't absorb anymore. Just thin machine oil, not thick oil. Now, we had a Gottlieb earlier on. It was a Gottlieb North Star, where the customer presented it to us with only scoring about maybe 2 points on a 5-point hit. And what the problem was this 2B, the actual, I'm trying to get in there, really going to have to get one of those, there it is there. That was broken. The actuator was broken off at the end. So it was releasing too early and only allowing it to score 2 points. So they're the things you've got to look for. And as a lot of people know, on a lot of games, the score motor has a jack, which is here, and you can put that into a service position, and you can manually turn the score motor to see what's going on, and you can look at it operate. Now, the other thing they did on these games is to ensure the score motor gets back to home position every time, they have a run-out switch. Now, on a Gottlieb, it is always stack 1C, and it is always the inside switch. So it's always that inside switch on 1C. That ensures that the motor, so that's a normally open switch, it's open now. And as soon as I run the motor, it closes, and it won't open now till the notch falls into place. A little bit hard to see, I think, that early in the morning with the sun coming in, but those notches obviously control that. Now, the big difference between a Gottlieb and, say, a Williams score motor is that not only is it horizontal, they can have differing amounts of switch stacks. I mean, there's one there with one stack's actually missing, but 1, 2, 3, 4, 5, 6, 7, 8 stacks, right? But yet we have a bally game here, which 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, that tells me 12 stacks that it's out of a later model game where they had more features and the machine needed to do more work. The switch stack's obviously missing off this one. Now, the interesting thing here about these is that when you're talking about one of these games, they talk about index and impulse. Now, these are 180 degrees, so every 90 degrees things happen. So we have a dwell here. So the switch stacks would fall in there, and they would be there. That one just fell into place. So that switch stack's in place here on this one, there. And this switch stack here would be, everything would be changed, the position of the switches. These are spaced 30 degrees apart, 30 degrees. So if I advance that, the third stack there will change state. See, it just fell in. Then you watch the next stack. It'll change state. There it goes there. And the next there, and the next there, and the next there. And the last stack, notice it's got the notches again, like the gear notches. That is the impulse. So that's the one that click, click, click. That's like for scoring and resetting. Okay, so that's how they work. They too have a score motor, exactly the same. Pretty much all the score motors were made by a company called Multi Products in the US. That's a motor off those people, which is almost identical to that motor there, except it's got a big shaft coming out of it. So they're all made by the same people. And you can repair those, but that's another total different story. So it's important to know also that on a Williams game, this switch stack, which would normally be here, the top switch, like here, that's the motor run out switch on the first stack. So what they normally do, they normally say, well, that's index, so that'll be then stack 1, stack 2, stack 3, etc., right up to impulse. Now, some games, like this Bally here, have a couple of impulse. See that? They've got a few different impulse cams to do different things. So you just got to read the schematic to. They generally always start to the left. And these style of score motors, and it's always the way, the bottom switch is switch A. So it goes A, B, C, D, E. So A is on the bottom. That's what you have to remember. Well, there's not much more I can probably explain to you. I hope that gives people an idea of how a score motor works. It's all to do with timing, opening and closing switches at the right time. If a switch is dirty and it's an impulse switch, it'll be mistimed, so it will fail. And obviously you need to check the wires on the switches, and bear in mind that on a Gottlieb game, between about 1959 and maybe 1962, thereabouts, the solder joints came loose, so you need to jiggle them up and down and pull them to make sure they don't come off. Obviously, that's a good rule of thumb for all games, and watch out for continuations. And also be very careful if you want to take any of those switch stacks off, which you can do by undoing these screws here, that there's not a wire running from, like in this one here, there's a blue wire there, this blue wire. Now that actual blue wire runs all the way down to a switch on the bottom. So that's a bit of a nuisance. That's taking power from one switch to another. I have to undo that stack. Fortunately, some were just soldered. This is wired. It makes it a little bit easier. So thanks for watching. This has been another Goat's Head presentation.